Hi guys, welcome back to In Case of Econ Struggles. Today I'm going to talk about cost-benefit analysis with time discounting and how to use net present value. Timestamps are below if you would like to jump around, but let's go ahead and get right into it. So like I said earlier, I want to talk about the big picture and sort of paint an example for what we're going to do. So our main problem that we're facing is we want to think about if it's worth it to clean up this park or not. We got some trash on the mountains, we got some dirty water, we got some fish that aren't happy. And so what we're trying to think about is it worth it to pay the cost now to clean up this lake, even though we're not going to see the benefits until later? And so just to be a little more specific about that, if we started thinking about the costs and benefits of cleaning up this park or not, you could say, well, on the cost side, it's going to cost us maybe 50 in order to pick up trash. In terms of units, maybe these are thousands, maybe these are millions, but I'm just going to make the numbers a little simpler by making them small. So maybe our cost to pick up the trash is 50. Maybe in order to clean up this lake, we've got to install some sort of water filtration system. And so that's maybe 100 to just install it, and then 20 per year to run it. On the benefit side won't start happening until this park has been cleaned up. And so the benefits are going to come later. And so, for example, if we think about better fishing, which maybe we value at 20 a year, and so maybe people are just willing to pay more in order to hike because of the fact that the view is prettier. Maybe if we clean up this park, the number of fish and the number of game will sort of come back. So maybe similar to better fishing, maybe this park can now sell fishing permits and they're going to get a benefit out of selling fishing permits. And maybe just the value of human enjoyment of all these cute animals, of the fish, maybe that's an extra 10 a year. And so again, if we're thinking of a horizon of, I don't know, maybe 20 years, you look at this and you say, okay, well, this trash pickup cost, that's going to happen now. This installment of the water filtration system, that's going to happen now. This is going to be per year, so this is going to happen later. But all of these benefits are going to happen later, and so if we want to compare the costs and the benefits, they're not necessarily in the same time, and so we can't directly compare them. So the present value of money or time discounting is what's going to allow us to sort of make these two things comparable. And so one way to think about it is to think about it as if we are converting between units of currency rather than just dollars over time. So for example, if I had euros and dollars, well, if I'm trying to compare a cost in euros and a benefit in dollars, again, those are not directly comparable. So what I could do is I could use the exchange rate to convert the euros into dollars. Well, now my costs are in dollars and my benefits are in dollars. Now I can just ask which one's bigger. And so for the same reason, if you're thinking about dollars tomorrow and dollars today, or dollars in the future and dollars today, we're going to use the interest rate R, which is also going to be sort of our discount rate, in order to convert those units and to convert dollars tomorrow into dollars today. So then I can compare costs and benefits because they're both going to be in terms of today dollars. And that will help me figure out if it's worth it to clean up this park or not. And so our equation for this is going to be that dollars today is dollars tomorrow over 1 plus R. And I'm going to tell you why I think that makes a lot of sense using just a really basic example. So for this example, let's suppose we got Bill, and Bill's going to put this dollar into the bank. The bank pays interest rate R, and he's going to put it in the bank for 2 years. Well, after the first year, what's going to happen if Bill were to take out his money, he would get the dollar back. But we'd also get a couple extra cents, which is these badly drawn coins that you see in green, because he gets interest R. So how much does Bill have in his bank account right now? He has 1 times 1 plus R because he put in a dollar, and he's getting 1 plus the interest rate. If he keeps that money in the bank for an extra year, well, that 1 plus R is now earning interest, so he gets 1 plus R on that 1 plus R, which is going to be 1 plus R squared. And if he keeps it in for another T years, or T years total, then what he's going to have is going to have 1 plus R times 1 plus R times 1 plus R, which is going to be 1 plus R raised to the T. So what we can do is we can call the amount of money that Bill has in his bank account in some future period, we can call that the future value. And the future value is just the present value times 1 plus R to the T, which is what I've drawn or written down right here. And so what we can say is, well, that's the amount of dollars that Bill's going to have in the future. But how many dollars would Bill have to put in the bank today in order to have some amount of future value in the future? Well, that's just the present value, and we're just resolving this for present value, which is future value divided by 1 plus R to the T. And so this guy right here is really important because that's what we're going to start doing. So now what we've got is we've got a way to take future dollars and convert them into dollars today, which is the present value of those future dollars. And now what we have to think about is, well, now in that example, we had a certain amount of dollars we were getting or paying per year, which is sort of like a stream of payments. And so we need to figure out how exactly do we figure out the present value of a stream of future payments. Just to make it a little more clear what I mean by a stream of payments, suppose again your bill, and now suppose that you're winning the dollar amount equal to the day of the year. So tomorrow on the first day of the month you get $1, Second day of the month, you get $2, $3, $4, all the way to the 31st day of the month when you get $31. And so the question would be, what is the present value of those stream of payments? And what we can do is for each payment, we can just use our present value discounting just like we did before. And so what we have is on the first, that's 1 plus r because that's 1 day from now. When we get the $2, that's 1 plus r to the second because that's 2 days from now. And we can do that all the way up to 31, where we're taking 31 and dividing it by 1 plus r to the power of 31, because that's 31 days from now, and so we need to discount that all the way back to today. Now, one thing that's not very useful about the way this is set up is there's no easy way to solve this sum. I'm going to have to go for each individual day, going to have to divide the amount the bill gets by 1 plus r to the appropriate power, then I'm going to have to add them all up. And so while that would work, that's not really useful. Instead, what would be way easier if Bill just got the same amount of dollars every day. So now suppose that we only get $2 a day, because then this would be a 2, this would be a 2, this would be a 2. And what that would look like is now this is going to be sort of a sum, because I could say this is the sum, this is the sigma operator for sum. This is from t equals 1 to 31, and this would be just 2 over 1 plus r to the t, where 1 over 1 plus r is less than 1, and so we're sort of looking at what we call a geometric series. We're going to need this for both the finite and the infinite case. So let me show you how we get sort of those equations to figure out the present value of future income streams when they're the same amount, both in terms of the infinite and the finite case. And I'm going to start with the infinite case just because I think the infinite case is easier. And so what we have is we have t equals 1 to infinity of future value over 1 plus r to the t, which just looks like this if I were to start writing out the sum. And what we really want is we want this thing to start at 0, because if we have an infinite sum that starts at 0, we know that's an infinite geometric sum, and the sum of an infinite geometric sum where the common factor, or 1 over 1 plus r, is less than 1, well, that's easy. That's just going to be future value over 1 minus 1 over 1 plus r. So that's what we're going to use. How can we take this sum that starts at 1 and transfer it into 0? Well, what I notice is I have 1 plus r to the 1, 1 plus r to the second, 1 plus r to the third. So what I can do is I can take out a 1 plus r, and if I take a 1 plus r out of that sum, this now becomes 1 over 1 plus r to the 0, 1 plus r to the first, 1 plus r to the second, because again, we have this common multiplying factor outside. And so what I can do is I can keep that 1 over 1 plus r there. This becomes the sum from t equals 0 to infinity. And so I know that the value of that sum is 1 over 1 minus 1 over 1 plus r. I know that this is the thing that I could pull out. And so if I just do the algebra, this I'm going to make a common factor like this. And so it becomes future value over r. If that's a little confusing, take a second, pause the video, look at the math, see if the math see if you could figure out how to do it. If you need to go back and watch this part again, totally fine. But I think if you do this a couple times, you'll see that this makes sense. And now you'll know that the sum from t equals 1 to infinity of the future value over 1 plus r to the t is just future value over r. But also, if you're taking an exam or you're struggling, you know how to get it. And you can always rederive it in real time and get the formula that you need to use. So with that in mind, we're going to go to the finite stream. So now you're only getting it for n days. So this is like you're winning $2 a day for 31 days. But this is for any value, and this is for any number of periods n. And so what I'm going to do is just derive this formula, because the formula that you see in the bottom of the pink, that's the formula you ultimately need to know. But I think just trying to memorize that is not very helpful. I think if you understand where it comes from, it's going to make a lot more sense. And so just stay with me for some of the math. So if I were to take the sum from t equals 1 to n, I can split this up into basically an infinite sum minus the later half of the sum. And so the infinite sum part, that's just going to be t equals 1 to infinity of future value over 1 plus r to the t. Okay, we just did that. We know that that's future value over r. This sum, on the other hand, we don't quite know what it is, but I can do the same sort of story that we did with this guy, where I just pulled out 1 plus r to the 1. This starts at n plus 1, so I'm going to pull out a 1 plus r to the n plus 1, and then I'm going to be left with that same infinite sum that we know and love. And so here's what I've got. I've got 1 over 1 plus r to the n plus 1. I've got times 1 plus r future value over r. And so this is what it looks like after I do the algebra and sort of put them together, because one of these 1 plus r's is going to cancel. And now I'm just going to do exactly what I put up front, where I'm going to take the infinite sum and subtract the later half. And when I do that, and when I do the algebra, this is the formula that I come up with. Again, take a second, see if you can match that formula. Let me know in the comments. If you can't, I can always add a second video talking about how I get that in more detail. But I think ultimately what you're going to see is this is the formula for finite stream. where it's future value times 1 plus r to the n minus 1 over r times 1 plus r to the n. Okay, so let's go back to our example. So now we've got all the tools we need to solve our example. And so again, what I've done is I've just taken our costs and our benefits and I put them on sort of like a timeline diagram. I think a timeline diagram is sort of helpful, especially if you've got a bunch of different pieces, because now you could sort of think about what's happening when. So notice what I've got. The first period, we pay our cost for the pickup and the water installation. And then for periods 2 through 20, we have that minus 20 because we're paying for the annual maintenance cost of this water filtration system. But we've got all these benefits, and when I did the math, this came out to 130, which means that on net, we've got minus 150 in period 1, and then we've got 110 all the way until the end of our horizon at t equals 20. So now we're just going to use the math. So now what I've got is I've got 150 over 1 plus r. My benefits start in period 2 and they go to period 20, and I'm asking if that's greater than, equal to, or less than 0. So what I'm going to need to do, and what I forgot when I did this originally, is I need to divide this by 1.0r because I've got a 2 and I need to discount it by 1. And so now we can use that formula where I've got 1.03 to the 20 minus 1 over 0.03 times 1.03 to the 20. This is 1636 divided by 1.03. I'm not sure quite what that is. Feel free to let me know in the comments if you got it. But basically the important thing here is that that sum is greater than 0, and so my benefits outweigh my costs. And so I should clean up this lake and I should pay to pick up this trash, even though the benefits are happening later and the costs are happening now. Even when I use present value to make all of those time periods and the dollars and all those time periods comparable, the benefits still win. The benefits are still greater than the costs, so I should still do this project. So again, hopefully this just helps a little bit in terms of what we're trying to do with net present value and the formula for net present value. If you've got questions or comments, feel free to put those below. But if these videos in general are helping you out, please like and subscribe, and we'll see you next time for another case of Econ Struggles.